So the previous example was all about figuring out all our odd numbers. Next thing to do is to take the same concept and see what happens with even numbers. So I'll change the question. Show the even numbers starting at, let's say, 10 to 20. Right, so we're looking for something like this. 10, 12, 14, 16, 18, 20. Now obviously we can see the method of it now. To get from 10 till 12 we had to add 2. To get from 12 till 4 we had to add 2. Again, it's all about adding 2. So I will change our starting number to 10. Right, let's see what happens when we execute this. There you go, it's all done it for us. 10, 12, 14, 16, 18, 20. But how did it do that? Let's look again. I number now starts at 10. We show 10 on the screen. We add 2 to 10 to give us 12. I number is now 12. We show I number, so 12 appears. And in the same method again to give us 14, 16, 18, 20. So we barely changed the original code for odd numbers to make even numbers happen because they both use a similar method to get things worked out. Right, let's try something more complex. Imagine I talked about Fibonacci numbers, right? Fibonacci, what's that you say? Well, the best thing to find out is to go into Google. So I'll fire up Google. I've typed in Fibonacci, spelled it incorrectly as I always do, and it bangs on about this thing called Fibonacci numbers, right? There's videos for it as well, lots of stuff on Fibonacci, so you can find it yourself by watching a video. What I'll do is I'll tell you what Fibonacci is, plus I'll delete all this stuff here while we're waiting. So, it is starting at 1, add 1 to it, gives you a 2. Now take the number you have, which is 2, and the previous number, so it'll be 1 plus 2 equals 3. And do that again. 2 plus 3 equals 5. Then do that again. 3 plus 5 equals 8. And it gives you a sequence of numbers called Fibonacci numbers. Right? Now, if you watch the videos about the Fibonacci stuff by searching on Google that I did, you'd find out it seems to be related to things in nature, although it's mathematics. Now, I'm not too bothered about the nature part of it at the moment. I'm just more bored to see if we can figure out code to show Fibonacci numbers. So what I'll do is, I'll make some integers. Int I number 1. And I'll set it at 1 because that's where the Fibonacci series starts. And then I number 2, I'll also set it as 1 because that is the next one you have to use. Start with 1 and also have a 1, add them together, gives you 2. Right, so first thing I'll do is, I'll show these on the screen. System, out, print. I'll do print, I want to see it all in one line now, that'll be interesting to see it. And I'll say I number 1 plus, let's put a space in, I number 2 plus another space. I'm using these spaces so every time I do this line, I'll use this line a lot, a couple of times, I'll copy and paste it. I'll have spaces between each time I use it. Now let's see what happens when we execute this. It should show 1 and 1, a 1 and a 1. There you go. So that's the beginning of the Fibonacci series. The next thing I have to do is I have to take these two values, need to take that one there and that one there and add them together to give me a 2. Right, so I have to look at how to do a 2 now. So let's go back up and try the code out. Now it takes a little bit of thinking, you might sit down with a bit of paper now to try and figure it out. But I'll say this, I number 1 equals I number 1 plus I number 2. So I'm taking the two values, I'm adding together, and I'm replacing the first one again. But the problem is this, let's scroll down to look. Since I've added those two together, I know I'll be able to show a 2 round about here. But then I'll also have to show the 3 next to it, because 2 plus 1 is 3. So if there's a 2 here, I have to take that value and one of the previous values, add them together to get I number 2, which appears next to the first one. And that sounds complicated. It is a little bit complicated. So I number 2 equals, and what I'll do here is, I've updated I number 1. I number 1 is now equal to 2, based on that line there. So I can say this, I number 2 is equal to I number 1 plus I number 2. I know it sounds strange, but because I've said 1 plus 1 is 2, that means this now has a 2 in it. So I can use that too. Also one of the 1s, and this one hasn't changed yet, so it's still a 1. So it's 1 plus 2 here gives us 3. Next thing to do is to grab that line above there and paste it in, and hopefully we'll see the next part of the series appear. Next set of Fibonacci numbers. Oh, spelling mistake, what you done wrong? I've done a mistake. That's okay. It's important to see mistakes. I've made a mistake here, obviously. So I need to go back and figure out where it was. It looks like round about line number 9. It says it can't find this symbol here. I'm like, oh wow, what's happened here? I have to go all the way back and look to see what I did wrong. Round about line number 9. Ah, look, there it's there. I used a capital U, so let's lowercase that. That looks terrible, doesn't it? I wasn't part of the way of writing things. And I've used a capital U there. So I'm seeing a few mistakes I've made. Previously I had notes before, and that's what happens with coding. You can make mistakes, but you can always go back and fix it. So let's try this and see if it breaks again. So it hasn't. There's the first 4 numbers. The next number will be a 2 plus a 3 is a 5, and a 5 plus a 3 is an 8. So I have to do that process over again. Now it's quite lucky because this is when it starts to repeat again. I'll grab all those lines there, every one of them, and I'll put them in. And then I'll execute it again, just to see what pops up. There you go, there's a 5 and the 8. So that means if I keep doing this, copy and pasting, I'll get the next 2 numbers again. So I'm just repeating the process again. Let's test what happens out. Just go back down to execute. There's the next bunch. Now the numbers actually got quite high quite quickly, so I'll do it again a few more times. I'll paste in the same stuff a bunch more times, and we'll see what pops up this time on the screen. There you go, we're up at 377, and look how quickly they're going up. Let's put a couple more in. And execute that, just pasting the lines again. We're up in the thousands now, right? So this Fibonacci series is worked out, which was a long time ago. It's related to things to do with nature. You can see the sequence building up quite quickly. It won't be long if I keep working on this to get into the millions easily, get into the millions quite quickly, but I won't because I'm going to stop.